Hi, everyone. Welcome to our presentation today, which will be on approaches to fraud detection. My name is Victor Palacios, and my co-host is Jinwei Sun.
Hello.
So today we'll be talking about autoencoders, isolation forests, and other methods that we can use to detect fraud. So before we do that, we'll tell you a little bit about ourselves and then a little bit about the KNIME Analytics Platform. So I'm Victor. I received my master's degree in data science from the University of San Francisco, and I currently work in the same field at KNIME. I love teaching courses on data science, machine learning, and of course, the KNIME Analytics Platform. My initial projects and interests were actually in deception detection and a little bit in healthcare as well. But really how I got started in this space is that I really found a passionate interest in machine translation and natural language processing. Jinwei, go ahead.
Yeah, hi everyone. My name is Jinwei Sun. I'm currently a master's student studying data science at University of San Francisco. I'm working as a data science intern and I'm with Victor. And before I joined this master program, I had a bachelor degree in business administration and concentration information system. So I had a working experiences in business and data analyst, and I found data science as the career path that I'm most interested in. That's why I'm choosing this as my career. Yeah, thank you, Victor.
Thank you. So let's get started with a little bit about the KNIME Analytics Platform. So in the KNIME Analytics Platform, you can, for instance, do data collection. So I can go ahead and grab data from APIs, from my Excel sheets, from my Google Sheets. And I can put them all together in the KNIME Analytics Platform, which is a free, open source, low-code tool. And low-code means that you can implement code if you like to, or you can use our nodes, which I will shortly show you a preview of, which perform different functions. So beyond data collection, KNIME can also do data visualization and even perform statistical analysis. Beyond that, we can also pre-process data. We can clean it, check it for quality. We can then go ahead and use machine learning algorithms in order to create models and evaluate how well those models are doing. If they do well, we can even send them into production with our deployment strategies. So KNIME is really an application that allows you to do the full data science lifecycle, but in a way that's more friendly for those of you who are not so interested in learning to program. Or if you do already have some programming skills, but want to modularize your work and make it shareable across teams, this can really help you with that. So let's give a preview of this. This is a KNIME workflow, KNIME Analytics Platform workflow. And you can see here each of my different nodes, which performs a specific task. So that's where the modularization comes in. So for instance, I can begin reading in my data from a CSV or other sources. I can transform my data from one data type to another. I can even partition, which means to split my data into a training set and a testing set, which is the typical paradigm for machine learning. I can then grab some machine learning algorithm, such as a random forest or an isolation forest. And once I've trained my model, I can write that model and then use it later on in production. Or I can use that model right then and there to perform predictions. Now, typically with our predictions, we give a 50% threshold, which means if our model has a 50% or above confidence of being of a certain class, we label it that class. In this case, fraud or non-fraud. But we can actually go ahead and make that even more specific, and I can change my threshold so that if the model is 30% confident that something is fraudulent, we label it as such. Then in this special node here, I can actually put together other nodes and I can create a dashboard. So for instance, I might have two visualization nodes within a single node, and that generates a dashboard, which is quite simple and easy in KNIME, and we'll show you that a little bit later as well. So the goals for this session will be twofold. We'll be explaining fraud and how to perform fraud detection in the KNIME Analytics Platform, first using labeled data. That will be my segment. Jinwei will then cover the second part, which is dealing with unlabeled data. And if you have any questions, please feel free to put them in the Q&A. Or if you can't think of questions now, but you've thought of them a little bit later, Jinwei will actually put our slides and Q&A section into the chat. You can go ahead and click on that link. You can download our slides now if you want to take notes. Or you can use that forum in order to post your questions that maybe you want to show a picture of your data. Maybe you want to share a workflow that you did with us. You can actually do more interactive things on this link here. But feel free to share your questions either in the Q&A or on this platform, and we'll respond to you. So let's get started with fraud. Fraud, at a high level, is the intent to deceive for some unlawful gain, typically some monetary gain. Now, if I'm looking at, for instance, a contract, I might find some suspicious items in there. For instance, the contract ID might be C0004, and with a fraudulent contract ID, I might find that it has not enough zeros or too many zeros. So the length of that contract ID could be something a little bit different than what we usually expect. With a payment amount, I might be looking for prices that are just a little bit too low or too high. And even for the dates as well, I might see something that has, for instance, a time before the company was even put into production. So that is probably not a real contract. As well, I might see contracts that are actually too far into the future. And so I can raise some warning signs on this kind of odd data. Now, this is just one example, which is quite simple. And of course, any human can do this. But what about the case where I have millions of PDFs and I need to find the fraud there? How can I go ahead and check for the IDs or the payment amount or the dates? What kind of analysis can I do if I'm not a very strong coder, for instance? Well, I can use KNIME and I can put together different nodes in order to perform a very similar analysis. For instance, I can use a node called the PDF parser. And the PDF parser simply asks, where are all these PDFs located? Once I give the location, I can then do a little bit of pre-processing magic, and I can get contract IDs extracted into their own column per the different PDFs that I have. I can do the same with dates, and of course the same with payment, and then perform analysis on each of these columns. Now, fraud in the real world, though, is not as simple as that. So we will look at a fraud detection dataset from Kaggle. Now, this dataset is actually based on European cardholders' data. So there's 250,000 plus credit card transactions in this dataset. And each of these transactions are actually represented by principal components. That is, they have privatized the different columns so that we cannot trace back to the certain people or customers that used or gave this data. We also have time as a column from the first transaction, and of course, the amount of money in that transaction. And we have labels, which are 1 for fraudulent and 0 otherwise. One special thing to note, as many of you who are in this domain know, is that fraudulent transactions are very low in the amount of times that they will occur. So for most data sets that deal with fraud, you're going to find that fraudulent transactions are less than 1%, usually much less than 1% of the total data that you're dealing with. In machine learning, we call this an imbalanced data problem, where you have too little of one class and too many of another. And so your models might be skewed to only learn about this dominant class. And so we have some tips and tricks as well for dealing with that. So before we dive into our first example, which is our random forest, I'd like to give you some background on how these models work in case machine learning is new to you. So in order to talk about the random forest, I first have to tell you a little bit about the decision tree algorithm. In the decision tree, we're asking the question, how do we best split our data such that we can capture fraudulent groups from non-fraudulent groups? So for instance, we begin with all of our data at the top of this tree, and we'll say that these yellow points are fraudulent and these black points are non-fraudulent points. We then ask a question, for instance, if I used the column amount of money and I set some a separator like less than $50 goes left and more than $50 goes to the right, what kind of separation of my data did I get? In this case, the separation is quite nice. I have the fraudulent points on the left, and I almost have all non-fraudulent points on the right. However, I still need to ask more questions in order to split my data again. So I might say, let's use time this time around. And if it's before the 1970s, which might be in this case, before the company has even come into play, then we will mark that as fraudulent. And anything else will go to the non-fraudulent side. So the decision tree is really asking a question. What column can I use? And from that column, what value is best in order to get the most homogeneous groups on the left and right side? And I continue to ask this question until I have fully homogeneous groups on either side. So I've isolated fraud, and I've isolated the non-fraudulent points. Now, when new data comes in, we use this tree and these rules that we've generated. And so new data will come in. Anything less than this amount will go to the left and be marked potentially as fraud. And again, anything that goes to the left will again be marked potentially as fraud. This is a very high-level overview of how the decision tree works. However, if I introduce new data, maybe it doesn't follow this pattern. Maybe amount should actually be in the second split, and time should be in the first split. But we won't know this ahead of time. So how do we fight this problem that our decision tree might make some bad choices if we only train one of them? Well, I can actually train a lot of decision trees, and each of them I can tweak to be a little bit different, so that one of the decision trees uses amount at the top, one of them uses time at the top. Then I can use a voting mechanism. So I can say from each of these trees, 3 out of 5 or 4 out of 5 are voting that this point is probably fraudulent. And so the decision tree incorporated many times is a random forest. You can think of it like going to one real estate agent, getting an estimate on a house, going to another, getting another estimate, going so forth and so on, until you then think about them as the average. And you say, I think this is about what this house is valued at. So this is really using the wisdom of the crowd in order to make a choice. Now, in terms of KNIME, we've earlier looked at this setup. And so now I want to show you how we can build this up in KNIME. So I'll go to the KNIME Analytics Platform here. And this is our modern user interface. And what I'd like to do is recreate some parts of this. So I'll come here and I'll type in what I'm looking for. In this case, I'm looking for the CSV reader, and I can drag and drop it. Then want numbered string to transform. And then I want to partition. I can then connect these together. And now I'll have to set up, for instance, which CSV do I want to read from? So I come here, I browse, and I plug in my data. Now you're thinking to yourself, okay, but is it possible to skip this left-hand side and perhaps auto-generate? And you actually can. With KNIME, I can drag and drop, and it will give me some predictions, what it thinks I might want to use next. So I go, okay, let's use the learner here. Then I can take this, which is the model, and I can say, okay, great. Now let's use the random forest predictor. And then I can connect the data here. This is a basic paradigm for machine learning models. And so just to show you a little bit more of the specifics here, when my CSV reader loads the data, I can get a preview down here. For the number to string, I can choose what variable I'm going to change. In partitioning, I can say, I want to split my data, and I want to do a 70-30 split. 70% of my data will be used for training, and 30% will be used for testing. And I want a stratified sample, for instance. Because as we talked about earlier, we're dealing with an imbalance problem where there are very few fraudulent points and a lot of the non-fraudulent points. So I want to make sure my samples are fair. I can then plug that into the learner, and the learner can then generate a model, which I can use later in production, or I can then generate predictions and check how well those predictions do. So to see how well my predictions are doing, I can actually look at this, which generates a very nice view. So you see I have a dashboard, which allows me to compare different thresholds. If my model has a 50% or above confidence in a fraudulent data point, it is labeled as such, or I can choose a 30% probability or threshold. I can then compare these models and say, okay, I can see recall, precision, sensitivity. I can even look at accuracy if I need to, depending on the problem that I'm working with, and the data, of course. All right, so that was a simple demonstration of our random forest modeling. And of course, Jinwei will also show you a little bit more demonstration with how these can work for you. Now, as we talked about, there were some sampling strategies that I was able to do. For instance, I could do stratified sampling, but that workflow that I showed you is quite simple. In KNIME, we can build up actually quite powerful workflows which do many different tasks, such as comparing different sampling strategies. In fraud detection, and especially with machine learning, when I have too many of the dominant class, or what we call the majority class, which is non-fraudulent data points in this case, my model might learn too much from them. So what I can do, for instance, is upsample. I can take the fraudulent data points and make synthetic copies or synthetic different copies, kind of like clones, but with slight tweaks of the original data. And so if I have 1,000 fraudulent data points and I have 10,000 non-fraudulent data points, I can create copies such that they are on equal pairing, so that both have actually 10,000 samples. In the reverse, I can undersample too, which is to say, I can, if I have 10,000 non-fraudulent data points, I can randomly sample 1,000 of them. And with my 1,000 fraudulent data points, now I have equal samples, so that my model learns about both the fraudulent points and the non-fraudulent points equally. So these are some advanced strategies that you can employ. And we have a link here in our slides, which will take you to this and actually show you a few other sampling strategies that we have. As well, on the right-hand side is the statistical sampling blog, which we go ahead and talk about in detail these different strategies. Now, another thing that we can do in KNIME, in the KNIME Analytics Platform, is to find fraud through deep learning. And we use the autoencoder architecture for this. Now, this one is always a little bit of a mouthful to get through, so I really like to use pictures here. What the autoencoder attempts to do is reconstruct the input. So whatever you're putting in as input, the autoencoder wants to try to copy that. How does it do that? Let's say, for instance, that I have a bunch of pictures of my cat who likes to wear glasses. The autoencoder will send the data through a hidden layer, and it will compress this data and only look for the most important parts that make this cat picture with glasses a cat picture with glasses. It will then try to reconstruct this image. And so it will give me something similar to what I originally had with sufficient training data. However, if I put in an image of a dog, which this network was not trained to learn on, it will not be able to reconstruct this well. So let's put this back into the fraud context. If I train my network on non-fraudulent data points, and then I insert a fraudulent data point, the network should not be able to reconstruct this point because it was not trained on such kind of data. So if the input in an autoencoder is similar to what it knows, then it is not fraud. But if the input is totally different, then it will be labeled as fraud. So that's a high-level view of the autoencoder. Now, to do the autoencoder in KNIME, which is a deep learning framework, we can use our Keras nodes. In order to use the Keras nodes, we need to define our networks. So for instance, we say that there are 28 columns that we're inputting. And we're going to compress that to 15, compress that to 5, uncompress and uncompress back to the original size, such that if we put in those cat images, hopefully on the end, we are still getting those cat images from input to output. Once we've set up this defined network, I will plug it into my Keras network learner. So just like before, we have that same paradigm. We first process our data, we then use a learner node, and then we make predictions. Then we can evaluate how well those predictions are going. If you'd like to learn a little bit more details on how this Keras network was built or something similar to it, and also kind of take a deeper dive into the pre-processing that is done here, or even how the autoencoder is evaluating, we have a really nice YouTube video that you can go ahead and check out by clicking on that blue link. Okay, so now that we've walked through my part of the session, which was labeled data, Jinwei will now walk us through unlabeled data. So let me stop sharing here and let Jinwei take it away.
Yeah. Thank you, Victor. All right, can you guys see my screen? Okay, thank you very much, Victor, for explaining how to do fraud detection using labeled data. Now I'm going to go through how to do it in unlabeled data. Before I dive into how to detect in unlabeled data, I want to explain the term fraud detection and outlier detection a little bit. Doing in labeled data, because the fraud data points are labeled, so we know some data points are fraud. That's why the machine learning model can find patterns in them. While we're doing in unlabeled data, we don't know which data points are fraud or not. Then we have the best practice to find fraud is through outlier detection. That's why sometimes they can be really similar and interchangeable, but there are still slightly differences. First, they both do detect abnormal data points, of course, but fraud detection are trying to find data points that is malicious, while outlier detections are trying to find the data points that is statistically different from majority of the data. What's the differences in here? Let me give an example. Suppose a fraud payment can be made different from the credit card holder's purchase behavior. Like it can be made in a different store, in a different website with a different amount. So this purchase can be easily determined as outliers because it's different from majority of the data, while it's also a fraud. In some cases, some fraudulent payments can be really clever. It can copy the credit card holder's purchase behavior. Like it can say it could be the same store with a regular amount of purchase. So we cannot find this as outliers, but it's still a fraud. The best way to find fraud detection is through outliers. Okay, now we know the differences and similarity between fraud and outliers. I'm going to go through the three methodology we usually use to detect abnormal data, unlabeled data: the visualization, statistic, and machine learning. First, let's dive into my visualization. There are many tools we can use to detect outliers through visualization. Here, I will introduce 4 of them: the bar charts, histogram, scatter plots, and box plots. In visualization tool, we're usually trying to find some data points that behave different than others. Like in this bar chart, how this column, this bar is way further than others. And in here, this behave different than others as well. In scatter plot, some data points are far away from other dots. Then we will say, oh, these data points are outliers. To implement this in lines, it's very simple. We can use column manager to give some data points, some colors, and we can use bar charts nodes, scatter plots nodes, all these graph nodes to just input the data and visualize it with a tool. Some pros and cons to use visualization technique is they're really easy to see as a graph we can see before, and outliers can be easy to spot on, and we can easily to interrupt which data points are outliers. Some cons is because it's a graph, we can usually only see 1 or 2 dimensions. If the data point is not crazy, then we might be able to see 3 dimensions. Also, this is a manually checking process. We have to manually decide which data points as outliers. Because we manually selected, so we may need some further explanation, like why data points you think is outliers. If the data set gets crazy or too large, sometimes it's really hard to draw a boundary to see which data points as outliers. So how to do this in the automotive process? This is where we introduce statistic. I'm going to go through IQR technique first. This is a really common technique that people use to detect outliers. The step is really simple. I'll go through one by one. First, we're trying to find the median of the whole data set, which is this line right here. And then we'll find another median of the upper half, Q3 right here. And one more median of the lower half, Q1. So at the end of the day, we have 3 medians right now. Now we get IQR score, which is Q3 minus Q1. Then we have decided arbitrary value of K. Usually it's 1.5, but if you want to be more extreme to detect these outliers, you can have a higher number. If you want to be lower and not extreme, you can have a lower number. But here we determine as 1.5. Our data points is outliers if the data point is larger than Q3 plus K times IQR, which is this line right here, this boundary. Or the data point is less than Q1 minus K times IQR, which is this line right here. So these 2 data points is above and below this boundary. We will say these two data points is outliers. To implement this in KNIME, we can use 2 nodes. First, we can use the numerical outliers nodes. We can select the columns and decide the K values in here. Or we can use the box plot to visualize some data points that be outliers. Okay, this is the IQR technique. Now let's go through the Z-score technique. This is really similar to IQR, but it's a lot simpler steps. First, we'll convert all the data to its Z-score, which is the data's value minus the mean and divide by standard deviations. Then we'll decide a threshold, which is 2.5, and you can be higher or lower, depends how extreme you want the outliers threshold to be. For any Z-scores, absolute value is larger than the threshold, then we'll say this is the outliers, which is that any data points that cross this line or the data point that's larger than this line. If you want to know more about how to do feature scaling like Z-score, min-max normalizations, feel free to click this link as well. To do this in KNIME, we also use 2 nodes. First, we need a normalizer node to transfer all the data value to its Z-score. And then we'll use a rule engine to have an if-then statement to create a new column to say if this data point is an outliers or not. Okay, now I'll show a quick demo how to implement this in KNIME. This is a really typical KNIME interface. This is a workbench, and there are many components, but we're only interested in this workbench right now. So let's zoom in. This is the data set that Victor mentioned earlier. We read PDF files, and we have components to extract date, ID column, and payment in it. Let me show you what the tables we get out of this. So right now, we have a table that has row ID, contract number, date, and payments. Right now, we're only interested in to find outliers in the payment columns. Okay, let's see how to do it in IQR technique. First, we have a numerical outliers nodes. Let's click it. We can select the columns that we're interested in to find the outliers on. And we'll select our input a K value, which is 1.5 usually, and it's 1.5 here. So click apply and OK. Now execute it. So we can see, now we can have a summary, so which row is the outliers. We have one outliers here. Or you can use box plot to visualize the outliers, which is the same as you select the columns that you want to see outliers on, click apply. Okay, now execute it. Now you can see a plot with median Q1, Q3, and also the boundary. And there's one data point way above the boundary. We can see this is the outliers too. Great. Now let's see how to do this. How do you do this in for Z-score technique? First, we need a normalizer to transfer all the values to Z-score. You can do min-max normalization, select the min-max value you want to, but here we're gonna forcing everything into Gaussian distribution which is Z-scores. And then we can select the columns we're interested to find outliers on. Click apply. Okay. Now execute it. So in here, all our payments are transferred to its z-scores. And we'll have a rule engine. In rule engine, you can create an if-then statement. If the payment has z-score larger than this value, then we will say it's outliers. Yes. And if it's not, then it's no. So click apply. Okay. Let's keep it. Okay. Now we have a new column to say it's outliers or no. Most of them are no, but we can see one column says this is a yes. So this is outliers based on this score technique. Okay. After seeing how to implement statistical methods in KNIME, let's see why do we care for statistical technique? First, because we want to do this in the automated process. Visualization has to manually check in, where statistics can be done this in an automated way. And it's really easy to understand as well, like the step I explained it. It's very intuitively understandable. And in KNIME, you can implement this with only 1 or 2 nodes. The cons is you might need to know a little bit about statistics, but the step is really simple. And this technique can only do in unidimensional analysis, which is we can only do this for 1 column, which is the payment we done in the demos. For this score technique, we have to force the data into a Gaussian distribution, which is normal, but sometimes might not be ideal. In that case, you can use IQR technique. So both statistic and visualization has been done for unidimensional space or 1, 2, 3. So how about multidimensional analysis? How to find outliers in multidimensional? First, let me quickly explain what is multidimensional outliers. In this graph, we have hourly work and salary. Usually, the more hourly you work, the more salary you will receive. However, in this graph, you can see this data points has a few hourly work, but with a high salary. So we can see this data points as the outliers. However, when we project it to unidimensional space, you can see this data points is not outliers at all because it's not an extreme value. It doesn't have a value, it has a value that is larger than him. So we'll say in unidimensional space, it's impossible to detect outliers that is multidimensional. This is only 2-dimensional and it's in a graph, so we can easily to interpret it. However, if you consider this in a 4, 5, or high dimensional that cannot be visualized, this might be really difficult. That's why we recommend to begin to search a multidimensional outliers, then dive into unidimensional. Okay, now let's see how do we find detect multidimensional outliers in machine learning methods. I will mostly discuss 2 of the methods. One is isolation tree, isolation forest is a tree-based, or DBSCAN, which is a cluster-based. For isolation forest, we want to see some data points are easily to be separated or isolated compared to others. For each of the separation, it's randomly choose one of the columns and random choose one of the value. We want to do this many times to see how some data points are easily to be separated or isolated compared to others. For instance, we can just use the example we had before. Let's say we randomly select a column, which is age, and randomly select a value, let's say 20. If the person is younger than 20, go to the left, older than 20, go to the right. And in here, we'll select another column, let's say salary. If the person make less than 100, go to the left, more than 100, go to the right. So we continue doing this many times. One tree can cause some noise and might not be able to figure out which data points are easy to be separated. If we do it in many times in a forest, then we'll have a voting mechanism to see how some data points like these red dots are easy to be isolated compared to others. Then we will say this is the outliers. To implement this in KNIME, it's a really typical KNIME machine learning workflow as well. We first read the data. For isolation forest, we have to convert it to H2O frame, and then we have a learner, and then we have a predictor. We connect this predictor, and then we will transfer it back to table. Then you will have all the outliers detected through this machine learning isolation forest methods. and you can create a rule engine to create a new column to see which data you consider as outliers. Okay, this is for isolation forest. Now let's go to DBSCAN. DBSCAN is a cluster base. There are five types of points, but here we only care about two because we only want to know if some data points is outliers or not. We first want to, for any data points that is in the epsilon environment that we decided will be the cluster points. For any points that is not being clustered will be noise points, and this is the outlier, and it's outliers. In this graph, we can see some of the data points are clustered together, whether they are far away or a little bit closer, but they are still within the epsilon environment that we decided. For any data points that has not been clustered in any of this group will be considered as a noise points and their outliers. Okay, now let's see how this actually be done one by one. In the step, first, we want to have an epsilon environment. To be decided, we have a bunch of points. And we randomly select 1 point. And we have decided with the epsilon environment, so we draw a circle. For any data points that is fall into this circle, we continually join points. We join more and more until there's no other points was selected in there. So any data points that has not be fall into this cluster, then we'll consider not in this group at least. And then we'll continue doing this until all the data points was either be selected in the epsilon environment as a cluster or outside as outliers. To implement this in KNIME, it's very simple. We can have 4 nodes too. First, we read the data, and then we have a normalizer node to transfer all the columns in the same range. Because sometimes some data sets column, the specific column has a higher range compared to others. For example, like in salaries and age only range from 0 to 100 mostly, but salaries can range to millions. We don't want the 1 columns to dominate all the distance. That's why we need to normalize it to transfer all the data to all the columns to the same range. Then we have a calculate its numeric distance for different data. And then we use DBSCAN to calculate all the distance, and we can implement it and find out the outliers through here. Why would we need to use machine learning to find outliers? First, to extract the outliers is all automated process. So there's no manual check-in. Also, the process is really simple. And we can do multi-dimensional analysis to find the outliers through here. For isolation forest, it's non-parametric, which means we don't care the data's distribution, and we don't care like the distance between them. For DBSCAN, it's really easy to implement in KNIME with only 4 nodes. However, some cons, DBSCAN can be really slow sometimes, and for machine learning methods, we have to turn some hyperparameter, like the epsilon value. We might need to test it out to find which epsilon value is the best suitable for your data sets. Okay, that's pretty much it for all. Let me give you a summary. From vectors, you learn how to detect labeled fraudulent data through autoencoder and traditional machine learning models like decision tree and random forest. For unlabeled fraudulent data, you can use visualization tool, statistic, and for some machine learning method, you can use isolation forest and DBSCANs. If you want to know more how to do random forest model for fraud, feel free to click this link. There's a workflow in here, and for multimodal comparison. If you want to deploy the fraud model, you can click in this note. So for more KNIME-related links, if you have any questions regarding KNIME, you can click here and people will answer you very quickly. And if you want to see any workflow, other workflows regarding fraud or any other workflows, feel free to click this link. If you see some free courses regarding KNIME, you can click here. We also have some more resources here. If you want to get a certificate and post it in LinkedIn, you can go to the certification notes. Okay, we have a sprint summit coming out. I think Victor have more information to share probably.
Yes, so every year we have different summits, and this one is going to be in Berlin. It will be online and on site. So if you're in the area from April 17th to the 19th, please go ahead and check us out. Last time, for instance, in one of our summits, we had Wendy Guan, who works at Harvard, and she's helping us develop geospatial nodes. So hopefully for April, we will have just as really amazing, cool speakers for everyone to listen to.
Yes. All right, that's all. Now let's answer questions.
Yeah, so we have actually a lot of questions. So I would like to try to go through those one at a time and just give each one, an appropriate amount of answer. So we said here for Christopher, it says, can we set up the model to work with unbalanced data? Since this is the case for most fraud data sets, absolutely. So yes, that is the case for most fraud data sets. And Jinwei, if you want to turn off your screen share so that we can, yeah, perfect. So yes, that is the case with most fraudulent data sets. And so we do have several articles listed in the slides and links where you can go ahead and check out the different sampling strategies and see how best you want to attempt to balance your data. Parker is asking, can you use a rule engine in KNIME with multiple inputs? For example, outputs from multiple models, other data sources containing decisioning attributes. Yes, you can. So the decision tree the rule engine, for instance, can take in and deal with multiple columns. So for column A, for instance, I want greater than 50 labeled as such. For column B, labeled as such. And if you want to, for instance, have these a little bit more organized, you can even use the node called column expression, which further gives you access to Java coding as well. So you can do that if that interests you. And then I will show actually the link for that. So what I like to do whenever I have questions like this is to go to, for instance, Google, and I type in rule engine multiple rules KNIME. As soon as you include the word KNIME, you typically get access to the KNIME forum. And on the forum, people ask very similar questions talking about how would I engage multiple rules or multiple sources. And then you will have different users who are more experienced or ourselves go ahead and answer your questions, showing you different workflows. And so I really love the KNIME forum just for this type of question. But yeah, we can take this also onto our site that we shared with you. And so if you feel like you still don't get it, you can post on that site and we can walk through whatever your problem is individually as well. Okay, next question is, can you share examples of fraud detection for healthcare? So at the moment, I do not believe we have a specific example for healthcare. So I've taken that down as a note. And if we have those, we can share them later on our site that we are hosting all the questions and Q&A for this chat. Can KNIME perform time series sampling, splitting, train, and test set based on a time attribute rather than randomly? So yes, KNIME can actually do that. So again, I went ahead and looked for the best things that we have to offer. So we do have an article, for instance, which covers time series analysis using components. And components are those special nodes that hold other nodes to perform one specific task. So for here, for instance, I can aggregate by granularity, taking these timestamps, transforming them into different timestamps. I can do timestamp alignment, etc. So let me actually put this in the chat for those of you who are interested in time series. As well, we have a book called Codeless Time Series Analysis with KNIME, where we go more in depth on these different strategies and the nodes and components that we used to build out our framework for time series analysis.
Yeah, I think Python might think the partition nodes will work for time series node as well. But actually, the partition nodes usually used for, I would say, regular data set. If you want to stratify that, different type of partition nodes that's basically for time series.
Yeah, exactly. And then can you output a KNIME model object to use in other platforms? Yes. So earlier when we were showing, for instance, the random forest learner and how it created a model, the model's format was PMML, which you may be able to then use in your Python workflows. Is there an EDA involvement on this data? Yes. So Jinwei's half of the presentation covered different strategies that you can use for evaluating your fraud or not fraud based on images. And so you can actually download that that workflow and use it yourself to generate that same dashboard that he showed. And then, if it's easy to spot your fraud with images, you can go ahead and use those as well, or some visuals, should I say. Okay, can you touch on the methodology for use for synthetic data generation for oversampling? Yes, so I actually prefer for this one to source you to the actual original paper for SMOTE. So a high-level overview is that SMOTE is short for Synthetic Minority Oversampling Technique. And basically what you do is you find all the attributes that belong to the fraudulent class or the minority class. And then you create clones that have very similar attributes to those fraudulent data points. So if most of the fraudulent data points have a, let's say, a time frame of 1970 to 1975, SMOTE will then create more fraudulent points with that time frame window, so 1971, 1972, in order to generate more samples so that your model doesn't rely too much on the non-fraudulent data points. But I really prefer the paper if you want to know the nitty-gritty there, but that is a high-level overview of how that works. Okay, any suggestions on how to use KNIME for cybersecurity? So just like with healthcare, we don't have a specific example for the healthcare field or for the cybersecurity field, but in the cases that we've showed, which were, for instance, dealing with purchases, we also have, for instance, dealing with strings to figure out if there are bogus emails happening as well. So I will also share these in our website page. So let me just take that down as show string detection for fraud for the cybersecurity question. Okay, and what else do we have here? Have you found yourselves tuning autoencoder to match the specifics of the fraud detection work at hand? If so, how? So I will actually direct you to our article, which you can find in the slides. Jinwei, if you have a moment to go ahead and look through the slides for the specific link on the autoencoder, isolation forest, etc. There's a blog in there. If you can grab that and put it in the chat for this person so that they can check out a little bit more details on the autoencoder. Okay, next is to use the isolation forest for fraud detection, do you need to have an idea of what % of cases are fraud? So no, you do not. For the isolation forest, it is taking a random column and a random value from that column. And so you can imagine that if a fraudulent data point has some obscenely high value or some obscenely low value, the chances of me picking some random value, like say 50, and anything below that, let's say that the fraudulent data point is like 2, right? So when I split, those points that have the obscene values are more likely to be quickly isolated or separated off by themselves. So you don't actually need to know a priori what is the case of fraud and the non-fraud, although it is good practice to know, because that helps you know whether or not your metrics are meaningful, right? If I have an accuracy of 99.95%, I might think this is fantastic. But when I look at the ratio of fraud to non-fraud, and I find that that is actually the ratio of 99.95% is non-fraudulent data, then my model is actually not performing better than baseline. So my model has done nothing. So you should know if you can ahead of time, but if you don't, then the isolation forest or DBSCAN are really good for not knowing ahead of time. Okay, I'm a novice at machine learning and I find KNIME useful. How can I learn about it? Yes. So Jinwei has posted near one of the final slides some different ways that you can pick up KNIME. So for instance, you might want to go to the certification pass, and those are free. So you can learn our L1 series and then our L2 series. Oh, and then someone is asking for the slides. So Jinwei, can you repost our link for the slides as well, please, so that people who have joined later may not have seen that link.
I do.
Yeah, so in there, Jinwei has posted for certification, for YouTube. We also have Just KNIME challenges where we do bite-sized examples of different problems that you can try to solve. And we do everything in those challenges. We do natural language processing, time series, ETL, PDF parsing. Okay. Can isolation forests determine feature importance, i.e. features that are strongest in separating the data? I have actually not encountered this question before. Let me do a little bit of research on that. So I'll take down this question. So feature importance with isolation forests. I would assume that if you have, for instance, a tree and each of the trees is generating splits, then you can go ahead and take the aggregate and say most of the time when, for instance, time is split at 1970 or something less than that, we find that it is a good way to determine fraud. So you should, in theory, be able to do this, but I'd like to give you a better answer, which I'll post on the forum. Okay, Keras or H2O needs Python or Conda installation with some dependencies. But unfortunately, Conda has become paid. In the future, will KNIME use another package manager? So I think you can still use Conda Personal for free, but we also have bundled environments in KNIME. So starting from earlier and even now in 4.7.1, you can, for instance, find Plotly as something that's bundled into your Conda environment already on KNIME. So you don't have to do those installations. As for Keras and H2O, whether those come bundled or not, I'm not sure, but we can definitely check that out and see if Conda has that issue with payment or not. So I'll write that down as well. Okay, is there a good way to try many thresholds for classifier score output and evaluate with a custom cost function? Yeah, so for instance, we were showing you just 2 thresholds, but of course the ROC AUC curve is one potential way to do this, depending on if you've balanced your data or not. If you haven't balanced your data, this might not be a good way to check those different thresholds. But if you have, then that might be a way to show how your trade-off between having false positives and the opposite occur throughout different thresholds. So that's one way to do that. Another way is you can just simply institute, like we did, 2 or 4 different thresholds and see which one works best for you. And then use the visualization tools or other tools to figure out that metric. And we have that in the slides for you as well, so you can download that. And just an idea, could Shapley be incorporated for feature importance? Yes, actually, we may already have this published, or we will be having this published, but we do things like Shapley, permutation importance, etc., in order to explain how well our models are doing and what makes those models work so well.
Thank you so much for being here. We really appreciate you taking an hour out of your day.
Yeah, thank you so much, Ethan.